Alright guys, now here in this video we're going to show you what we call a linear regression model as well as a quadratic regression model. So what I have is some data I've gathered, probably off the internet, and it's listing the price of silver um, over a 7-year period, right? Starting in 2005 when it was $7.31 an ounce to a 2011 price where it was 35.12 an ounce, and I'm trying to get a what we call a best fit graph for that data, all right, and use it as a predictor for future values. Okay, so let's take a look uh, through our calculator. I'll show you what end results I got here. Okay, and then we'll show you how we set that up. So basically, I'm going to look at the graph, okay, and I'm actually showing you the points that are plotted. But let me come and turn something off for you for a while so it doesn't look so confusing. Okay, uh, so here we are looking at the graph again. Okay, these are my data points that are plotted. Okay, we calling year 2005 year zero, where this is the starting uh, price of silver. And every one of these is a data plot. The line is what we call the line of best fit, okay, which is the linear regression line, okay. Don't worry whether it's a good fit or not. In fact, I can tell you it's not going to be a good fit, and neither is going to be a parabola trying to map these. But we want to go through the process, and later we'll find that, there are more sophisticated models, not linear or quadratic, but exponential models that best fit that. So don't worry about it being accurate or not. So as you can see there, okay, there is the line of best fit. There is the equation of that line, 3.7 x plus 6.67. That's 3.76. So I'll correct that. And then having that, having that equation, of course, I can just use that as a predictor for future values of silver if I can trust this equation as a model. Okay, so let's show you how we proceed with that. Okay, so what we're going to do is I'm just pretty much going to run through step by step on the calculator what we got to do here, and then show you how to manipulate, how to use that data to answer these questions. Okay, so we're going to go to apps. We're going to go to the data matrix editor in the apps. We're going to start with a new um, set of data. Uh, I'm going to call it, I have to call it gold 2 because gold was the previous one. So this is going to be gold. The alpha keys are activated. G O L D. Okay, and you can see that's typing it out there. And I'm just going to call it, turn off the alpha key and call it gold 2. Okay, and that's that. And then what it does then is it takes you to basically a spreadsheet where you enter your data. We're going to start with 2005 as year zero. Okay, so we're going year zero through year 6. Okay, 0, 1, 2, 3, 4, 5, 6. Okay, um, then we're going to put in the price for that given year. So 2005 year zero, $7.31, 7.31. Then we kicked it up to 11.54. Then we got 13.38. We got 20.09. We've got 1830. we've got 2019, and for our last data we have 3512. Okay, so all our data is entered. Wasn't too difficult. Okay, all your data is entered. If you incorrectly enter it, you go back and type over it. Okay, next thing, follow carefully what we got to do. F2, plot setup. F2, plot setup. In there, we want to define F1. Okay, uh, you want basically a scatter plot. That's basically all we ever do. Okay, uh, the symbols that you saw are boxes, crosses, X's, whatever you want there, plus signs. It doesn't really matter. Okay, uh, we want to tell it that C1, so you have to key that in. You might have to toggle the alpha key on and off to get C1 and C2 in there. Okay. Um, use frequency and categories. It doesn't matter much. We can opt either way with that. We'll take yes. Okay. It's not going to have any relevance right now. Okay. Enter that. Okay. And strike enter again, and it comes back to your table. Now we go to our calculator F5 feature, F5, and there we're going to define how we want to set it up. We're going to say we have all these different models. Okay, we're going to have the line regression that we're going to do is option 5, and then later we're going to come back. We're going to take option 9, which is the quadratic regression. Okay, so we're going to take option 9. That's a linear regression, not option 6, the logarithmic regression, and exponential option 4 would probably be our best bet, but we'll defer that until we talk about an exponential function. So we're taking line regression. We're going to tell it again. We're going to go to C1. So you got to key that in. Sometimes it's a little flaky. Sometimes you got to strike the alpha key or not. C1, C2. Okay. Let's see. I did not strike the alpha key, so you can see what happened. I didn't. I got the parenthesis there, so I got to take care of that and strike the alpha key. C2. Store the regression formula less. Yes, let's store it in Y1. Store it in Y1. Frequency categories, up to you. Take it, okay? So there, once you hit that, it will show you that the equation of the line of best fit is y equals ax plus b. A is, looks like it's 3.77x, plus b, which is 6.67. So that's right there for you. Okay, I have to correct that to 3. My eyes aren't what they used to be. Okay, now if you come back and get out of your data, go to the y equals, you will see that it's been pasted in there. Okay, there's your function that's been pasted in there. And if you view that in your standard window, you're not going to see much. You're going to see that, okay, which isn't doing you much good. So what I want to do is I want to F2, and I want to zoom all the way down to option 9, zoom to my data, and it's going to plot my points, as you can see there, okay, and it's going to give you the line. And you could do a judgment call. You say that doesn't look very clear, like it contains many of those points, and you know, it doesn't have to, but it's a sophisticated algorithm to come up with that line. It's called method of least squares, okay, which you ought to be thankful now that you have a calculator to do that for you, because when I had to do it originally, it was a lot of tedious work, and then you end up getting something like this, which is a long shot from a nice match. But now we have the calculator, which will get that for us in no time. Now we have that. How can we use that as a predictor? Well, you have the function. So year 2015 is year 10. Okay, so you can just evaluate that, plug it in, or let your calculator, you know, just go to your table set. take the ask option, and then go back to your table and plug in these years, 5, in which the model says you're going to have a value of $25.53 an ounce on silver, and the subsequent prices according to your model. Now, whether they're good or not you know, is your call, okay? But that's what the model predicts, and those are the values you can key in there, okay? And then if you want, and in fact I do ask, so I ask you to try another model, which is a quadratic model. So let's go back to our, we're back here at our, go back to our data. So you go back to the data matrix editor, open up the current one that you have, okay? And now go back to F5, and in F5, let's choose this quadratic model. Choose the quadratic model, it's option 9, okay? And again, come in here and key in C1 and C2. And C2, there it goes again, have to toggle that alpha key on and off, C2. And we're going to store this for comparison's sake in Y2, okay? And it comes up and it says, okay, here is the equation, y equals ax squared plus bx plus c, our standard form for the parabola, quadratic, okay, with the values of, what's it look like, 0.4375 is a, 0.4375 x squared plus 1.18 x, okay, and whatever that is, 8, okay, so whatever, it's over there in my y2, so I'm going to go over and I'm going to pick that out of y2. Let's go to y2. Y equals, there it is, 0.437 x squared plus 1.15 x plus 8.8. And of course, if I look now at my graph, looking at my graph, there's my linear regression. Here comes my quadratic, which seems to be maybe a better fit, but in reality, whether it's the best fit or not is, we really want some more data to be able to determine this. But regardless, we have a regression model of a linear form, of a quadratic form, okay, and if we go to our table again, we now have a comparison values for those years that we're questioning. The Y1 is the linear model, the Y2, the quadratic model. I only wish it was true, because then our silver would be worth a whole lot at this point. But okay, so later, like I said, neither of these models is a very good fit, and there's a couple reasons for that. Okay, um, the primary reason is that, we did not get a very good sampling. We would like to have maybe a sampling over a 20 or 30-year period, and also the fact is that uh, the line or the parabola is really not the best mathematical model to map this, and we'll show you that, well, I might as well show you right now. Okay, so I'm going to go back to my data and just show you perhaps that another model might prove to be a better, more accurate fit, and we're going to just do that just so we can show you. We'll come back to this in the second semester. We'll do the exponential regression, and again, keying in our C1, C2. Okay, that did not, so C1 and C2. And we'll just put this in y3. Okay, just so we can show you. All right, and that is a exponential regression. So we'll take a look at the picture that that one paints for us. Okay, let's just, for sake of argument, just turn off these y1 and y2, toggle F4, and we'll take a look at that. There's our data, and there's our curve. Okay, and then let's take a look at how that fits maybe as a more realistic mapping of our values. Let's see, the table right here. Let's take a look at the table, and I do believe some of that might be a little bit better, but again, we probably are best to have a wider sampling of data. Okay, so we'll have some of these models that we have to do for class, and that's that for now.